Hello, welcome to another functional skills lesson. This is another fractions one, and we're going to be dealing with, can we get the pen right? Mixed fractions and comparing fractions. Yeah. So first of all, we'll do the mixed fractions. Now we've done fractions before. We've had like 3/4 and 2/5, and we've understood the numerator, the divide line, the denominator. The numerator does the how many, the denominator is the size. But there is something called a mixed fraction. Now a mixed fraction is a mixture of whole numbers and fractional numbers. So here's the fractional numbers, and 2, 3, 99. These are whole numbers, so we can get 2.5. There is a mixed fraction. Now what we've got to be doing in this little lesson is converting mixed fractions to ordinary fractions and the other way around. Now this is 2.5, so let's have a look. So we've got 1, 2 and a half. Yeah, so we've got 1 whole 1, 2 whole 1s and a half. Now if we want to convert that to a sort of regular fraction, let's do that. Divide them all up into halves. So we've got 1, 2, 3, 4, 5, 5 halves. So that would be 5/2. Now this time the fraction there is, the number at the top is bigger than the number at the bottom, so we're going to call this a top heavy fraction. Now we need to do this later on in another lesson where we're adding, subtracting, multiplying and dividing fractions. So we need to be able to convert from mixed fractions to top heavy fractions, and from top heavy fractions to mixed fractions, backwards and forwards. Now this drawing out the little squares and half in them is okay as long as these numbers are small, but imagine we had 34 and 3/4. Yeah, we'd have to draw 34 boxes and divide them all up into quarters and then count how many we've got, and it's just too big. So there must be another way. There is fortunately another way. So we don't need to do that one, but that was just the example. So we'll do 3. We'll do 2.5. Let's the one that we already know what the answer is. Yeah. So let's do 2.5. How can we do this to get that without going through all the little boxes? So what you do is you take the denominator at the bottom, and you know that everything is going to be over 2. Yeah, it's going to be over 2 because it's so many halves. So what you do is you take this number here and you multiply the big number. So you take that one and you multiply by that one. So 2 2s are 4. There, 1, 2, 3, 4, and then you add that one to make 5. So 2 2s are 4 plus 1 is 5. 5/2. Let's do this. 3 and 3/4. 4 times 3 is 12, plus 3 is 15. So that becomes 15/4. Denominator. Yeah, so the bottom times the big number, and then the result of that you add the top number, the numerator. So 10 and 1/5 will be 5 times 10. Well, everything's over 5. Yeah, so 5 times 10 is 50, plus 1 is 51. Okay, we'll look at some examples of these in a minute. So that's how to go from a mixed to a top heavy. And they will always come out as top heavies because it's a load of whole numbers. Once you get past 1, anything bigger than 1 is going to end up as a top heavy. You can't help it. So that's how to go from mixed to a top heavy. So how do we go the other way around? So let's say this one, 12 over 4. Yeah. This is a top heavy. We will need to go into the mixed. And remember that this line here just means divide. So it's 12 divided by 4 is the thing we've got in our head. 12 divided by 4 is 3. So as a top heavy fraction, this comes out to be 3. Right, now let's do 14 over 4. What do we do with this one? So this is 14 divided by 4. So in case you can't do this, you might want to do... Oh, no, that's not a square root, is it? The square root. You might want to do this way. 14 divided by 4. So 4's into 4, 1 don't go. 4's into 14, go 3, which is 12. And you've got remainder 2. Yeah? So 3 4's are 12, remainder 2. So this comes out as 3 whole ones and 2 left over. 2 what? 2 fourths. And we could in fact simplify this. Remember the last lesson? 2 over 4. We could divide top and bottom by 2. So we could make that 3.5. So, oh, so ill. Okay, so let's do 23 over 3. So this is 23 divided by 3. And we need to change this into a top heavy, which is 3's into 23 goes 7. It's because 3 7's are 21, and we've got 2 left over, so it's 2/3. Alright, so that's how to go from a mixed to a top heavy, and from a top heavy back to a mixed. And once we get that under control or sorted, we can use that knowledge later on. So let's have a look at an example or two. So here we go. So we've got 2 and 3/5. Convert the following mixed numbers into fractions. So we've got that way around first of all. And then the second half is convert the following fractions into mixed numbers. So going the other way. So again, pause if you want to have a go, and then play, and I'll tell you what the answers are. Fingers crossed. So 5 times 2 is 10, plus 3 is 13. 13 over 5. 7 times 1 is 7, plus 3 is 10 over 7. 12 times 3 is 36, plus 5 is 41 over 12. And 13 times 2 is 26, plus 2 is 28 over 13. Alright, let's go back the other way. Convert the following fractions into mixed numbers. So we do 7 divided by 3. 3's into 7 go 2. With 2 3's are 6, so we've got 1 left over. 43 divided by 4. 4's into 43 go 10, because 10 4's are 40, so that's 10 with 3 left over, 3/4. 21 divided by 5. 4 5's are 20, so it goes in 4 5's and 1 left over, which is a 1/5. 27 divided by 8. So 3/8 are 24 with 3 left over. Okay, so that's going from mixed to fractions, from fractions to mixed. Right, let's go back and do the compares. Now, second part of this is comparing. Now, when you're comparing fractions, when you compare fractions, You're okay. It's easy if the denominators are the same. It's difficult to write with all of these thingies. If I had a pen and a piece of paper, I could write better. But it's much easier for me to do this rather than try and type all this stuff in. It's just so complicated. So all we're doing is comparing different fractions to see which is the biggest, or which is the smallest, or maybe we have like 3 or 4 fractions and we've got to put them in order starting from the smallest to the biggest. Now the complexity that you get with, hang on, things are falling on the floor. The complexity you get with functional skills level 2 shouldn't be too crazy, but we'll see. So 3/4 and 5/4, which is the biggest? Well, remember that the numerator tells you how many you've got. So because the denominators are the same, it's easy to say that this one is the biggest. Yeah. If you have 2/3, 7/3, 1/3, and 4/3, all this, and you put them in order from the smallest to the largest, all you're doing is looking at the numerators, seeing which is the smallest. So the smallest is 1/3, then you've got 2/3, then you've got 4/3, and then you've got 7/3. So it's as simple as that when the denominators are the same. But you should know by now it's never going to be that easy. So let's have a look at 3/4 and 2/8. Oof, denominators are the different. So the thing you have to do is make the denominators the same. Why can't they just say the bottom numbers? Make the bottom numbers the same. How do we do that? Well, remember when we went in a previous lesson we looked about simplifying numbers? Well, it's the same sort of thing. So what you do, general rule of thumb, look at the biggest number that you've got for the denominator and then make the other ones the same as it, if you can. Yeah. So you'll need to find a common denominator, as they call it. So if we keep that as it is, and then we're going to make this one here to be something over 8. So to get from 4 to 8, we have to double this number, or multiply by 2. So we have to do the same on the top as we did on the bottom. So double that gives you 6/8. So 6/8 is an equivalent of 3/4. And that's all you're doing, is you're trying to make equivalents so that you get all the denominators the same. If we have a half there, we're going to make that the same as the 8. So we have to multiply that number by 4 to make it an 8. So we'd have to multiply the top by 4. See, 4/8 is the same as a half. And now when you've got things with the denominators all the same, you can compare them. You can say, oh, that's the smallest, 4/8's in the middle, and 6/8's the biggest. And if we have 15/8, we'd know no problem at all. We don't do anything with that because it's already got an 8. So you're making things usually the biggest number that you can. Now let's have a look for a more complicated thing. Well, we haven't got any more complicated things. Yeah, yes we have 5/4 and 1 3/7. So we're going to compare these two. Now remember what we did just now with mixed. So what we're going to do, this is like a twofold operation here. We're going to change this into a top heavy and see where we go with this. Right, so let's change this into top heavy. I know 4 and 7 are not going to be the same. So 7 times 1 is 7 plus 3 is 10. So that comes out as 10 over 7. And this one is 5 over 4. Now we're stuck here because we can't double 4. That will be 8. And we can't half that because that would be 3.5. And we can't... Ooh. Right, so when you're in this situation, you multiply the denominators together. Right, so this is complicated now. This is almost like adding fractions, yeah? So 4 sevens are 28. So on the low we've got 28 and 28. So with common denominators of 28. Now what we did here is we multiplied this number on the left by 7 to get 28. So we have to multiply the top by 7 to get 35. And then, well, another colour. Let's we multiplied this number by 4. 4 sevens are 28. So we have to multiply this number by 4, which is 40. And now you've got 35 over 28 and 40 over 28, and you can compare. You can say that 40 is bigger than 35. Therefore, this is the largest and this is the smallest. So it's cross multiplying. Cross multiplying. You multiply the left-hand fraction by this number, and you multiply the right-hand fraction by this number, and you'll always get a common denominator. Let's do another one of those. 4 over 3, doesn't matter, we've made it top heavy. And let's have a look. 7 over 5. Now remember, we need to get a common denominator. So we're going to multiply the left-hand fraction by the number 5. So 5 threes are 15. 5 fours are 20. So now I'm going to multiply the right-hand fraction by the number 3. So 3 fives are 15. And 3 sevens are 21. Now you can compare because you've got denominators that are the same. Right, so the complicated, what if we had 3? Well, let's have a look see if we've got an example where they want you to do 3. So which is larger, 3/4 or 30 over 36? Let's make, see, 4 goes into 36. So if I go 4 times 9, if I multiply this left-hand one by 9, I get 4 9s are 36, and 3 9s are 27. So I get 27 over 36, and this is 30 over 36. So I can compare the fraction that is larger is 30 over 36 is larger. Now, what are we going to do here? Because we're going to put these in order from smallest to largest, and they've given us three different denominators. So we're going to pick on the biggest denominator, or maybe I'm going to do something with this to make it more manageable. Can you see what we can do with this fraction? We can divide by 10 to give us 12 over 40, 2 over 5, and 5 over 20. Okay, so it's a bit smaller, it's an equivalent, and I'm going to make everything 40ths. So this can remain the same, 12 over 40. Now, what do I need to multiply this number by to make it 40? 8. So 5 8s are 40. So I need to multiply the top here by 8. 2 8's 16. This one, I need to multiply this by 2 to make it 40. So I need to multiply that by 2 to make it 10. So now everything is over 40, and I've got 12, 16 and 10. And if I were to put them in order from the smallest to the largest, I would go 10 over 40, 12 over 40, 16 over 40. Right, this one looks a bit hard because there's some really difficult numbers here. We need to find a common denominator of all this. So maybe I can't do anything. I'm going to try and simplify these a bit. Can't do anything with this one, so I'll just leave it at 3/20. And this one, I could half that to be 3 over 12. I can divide that by 3 again to make it 1 over 4. Yeah, so I'm going to call that 1 over 4. 3 over 20. It's quite a long way around here. So I'm going to divide that by 9 to give me 1 over 6 9s of 54. 1 over 6. Oh, that's horrible. 1 over 6. So I've made them as small as I can, but they're still not happy with this. Not happy with this. 20, 4 and 6. So I've got to find a common multiple of all of these three, so to make it 20. So what I'm going to do now, and I would probably do this come the exam or something, I need to find a common number for all of these four. So I'm going to do up here, it's sort of in the corner of your paper, I would do 20, 40, 60, 80. There's all the multiples of 20. Now I do 4, 8, 12, 16, 20. That looks nice. But what about 6? 6, 12, 18, 24, 30, 36, 40. Does 4's go into 40? I think it does, doesn't it? 20, 24, 28, 32, 36, 40. So there is a common multiple of all of these numbers. So now I'm going to change everything into something over 40. So 3 over 20, I double it, becomes 6 over 40. 4, to get 40, multiply by 10, which gives me 10 over 40. And 6, that's 42, isn't it? 42, 48, 54, 60. It's 60. Yeah. It's 60. Does 4 go into 60? Very unlikely. Keep going. Keep going. Don't mind. 4, 44, 48, 52, 58, 62. Doesn't, does it? Wow, this is difficult. 66, 70, 70. Is there a common thing between 4 and 20? 5 9s, 6 9s, 54. This is so difficult. 74, 78, 82, 86, 90? 90? That's never going to work, is it? Right, so I'm going to come back here. Yeah, now you see how difficult some of these are. So I'll come back. I'll look at Mike and Leo now and come back to that one. So what can we tell about Mike and Leo? Hang on. So what page is that? Let's have a look. What a killer of a question. 16. Right. I'm going to have another go at this one. So, let's try a different colour, a nice colour, yeah? Now, did they say we could use a calculator? No, they didn't, did they? So, how on earth 3/20th, 6/24? So that is going to be 3/12. Divide by 3. 3/18. Oh, I see the way they want us to do that. So there you go. So I'm going to never come across one of these before. Don't like this. So going to make the numerators all the same instead of the denominators. Yeah. And then compare the denominators. This is an upside down question. So we've got 3/20. This, if I half this number, it becomes 3/12. And if I third this number, it becomes 3/18. Right, so the denominators are never going to be the same. So, but I've got 3/20, 3/12, and 3/18. Now remember that the denominators determine the size. So 3/12 is the largest, 3/18 is the middle, and 3/20 is the smallest. Oh, how so difficult, that one. Upside down. Mike and Leo are running laps of a field. Mike has run 5 7/10, and Leo has run 133 over 25 laps. Who's run the furthest? Well, we need to find out how many laps they've run, don't we? So let's do Mike. So what we're going to do is change that into a... No. We might leave that there. 5 7/10. And Leo has done 133 over 25. So what I'm going to do is, that's the top heavy, I'm going to divide 133 by 25. Now, 25s go 25, 50, 75, 100, and 125. And I won't get any more than that. So it's 1, 2, 3, 4, 5. So this equals 5. And there is 8 left. 25s into 133 go 5 times, which is 125, and there is 8 left. So I've got 8/25. Now, so we've got 5 7/10 and 5 8/25. So we need to compare the fraction because they've done 5 laps and a bit. So 7/10 and 8 over 25. Now I can multiply these up to be 50, yeah, by doubling this one and multiplying this one by 5. So this will be over 50, and 5 7s are 35. So this is for Mike, and this will be 50, and double that, 16/50. So Mike has done 5 and 35/50, and Leo has done 5 and 16/50. Yeah. So this Mike has run the furthest because that is a little bit bigger. Well, it's twice as big as that. 5 laps and a bit more. Okay, so that was a really tricky one, that B. Yeah, didn't expect that. Yeah, so that's the end of this one. And there'll be some self-study to go on this one. And I'll see you in the next one. Okay.